Welcome to Mastering Solutions. In this problem, let's make a list of everything that we're given. We're told that the focal length of the mirror is 15 centimeters. So we have a converging mirror. So the focal length is always, or the power of the mirror is always going to be positive. So we have 0.15 meters or 15 times 10 to the negative 2 meters. So that's the focal length. And now, what is the image distance? The image distance is where we're trying to focus the light. That's where we want it to be all converging to, right? And so we're going to treat the patient as that's where we want the light to converge. That 1 meter, that will be our image distance here. Now, what is the object distance? The object distance is the lamp and relative to the mirror. So the lamp, that's what's giving off the light, which we're trying to focus at the image distance. And so this is what we're trying to solve for. So we can use the thin lens equation. So 1 over the focal length in meters is equal to 1 over the image distance plus 1 over the object distance. This is what we need. So let's minus over the image distance. So 1 over object is equal to 1 over the focal length minus 1 over the image distance. And so we have 1 over the object's distance is equal to 1 over the focal length, which we said was 15 times 10 to the negative 2 meters. And that was positive, minus 1 over the object distance, the image distance, minus 1 over the image distance, which in this case was 1 meter. And so obviously in the calculator, this is just going to be 1. So we have 1 divided by 15 times 10 to the negative 2 minus 1. So we have 5.67 diopters. So 5.67 diopters, and that is positive. So that's the power of the converging mirror with this condition, but we need that in meters so we can figure out the distance. And so that's 1 divided by the answer will give us from diopters to meters. So we need to place the object at 17.6 centimeters. So we could say, we could just round that to 18. So we need to place it at 18 centimeters in front of the mirror in order to focus the light at this distance for the patient.